Well, it looks like we're having a bit of a base station bonanza at the moment, because here's another base station that's come in. This time it's the Commtel base. And what do you all know about that? Well, some of you may be surprised to discover that in actual fact it's a Cobra SOS, one of these emergency sets. It's the works of one of those, put into a metal cabinet here in the UK, and thus a base station by the time it was power supply to it. The story I heard was that back in 1983, the warehouse where the Cobra SOS emergency kits were being stored and distributed from had a fire. Now that fire didn't affect the products, but the smoke damage would have made them unsaleable. So they'd have stunk rather badly. And so I presume they were paid off on insurance at the cost price of them, and somebody bought them and decased them and put the works into Commtel base stations. In fact, this Cobra SOS is mine, and we'll do a service on this because I haven't done it. Look, they're the same knobs, aren't they? See? Didn't waste anything. So we'll do a microphone for this, and we'll run through its service procedure. We don't have a manual for it, but I do have a circuit diagram for the Cobra SOS, which, as I say, is what this radio is. So we'll stop the video at that point, take the lid off, and make up a microphone. Okay then, so we've made up a microphone and taken the lids off, and you will see the chassis, I can't say that, of the Cobra SOS, which is 39XFM inside. I would suggest that those Cobra 39XFM sets are quite collectible, because there won't be that many around, seeing as most of them got converted into these. Right, I've made myself a little chart up with the adjustments, which I made up from the service manual. I can't really go through the VCO with you because we don't have a proper service manual, and if I came up with one of these sets where the VCO was out of lock, I would have to work something out. It does use the Sanyo LC7137 IC, so I'm sure we could work something out. But the way this is arranged, with it bolted down to a solid metal case, it would be a real faff to take the printed circuit board out to start messing about with changing components even. So let's hope that this radio is just a service and that it doesn't need any components changing, because it's got nothing on the ticket. I've obviously got to provide a mic, and there we go. Now, it looks to me from the circuit that T3 and T2 are the VCOs. The fact they've put wax in that tells me it's the VCO. I presume that's also something to do with the VCO. Where the test point is anybody's guess. So I can't really cover that with you. What I can cover is the fact that the transmitter lineup is quite clearly that coil there. I'll just zoom in. So we've got, that's going to be the first transmit coil. Then where they've put a meter in, there's one down there. We've got then, I know that's L1, I know that one filled with wax is L2, and I know that that one filled with wax is L5. So what we will proceed to do is optimize the transmit on this. Well, it's doing 3 watts. So how much we can coax out of it more, I will find out. I've checked the power supply's running alright. It's doing about 3.1 volts, 3.2 volts. Actually, we've just gained a bit there. I've just changed ranges now. This test set has a 3 watt range and a 30 watt range. which is quite frustrating. I wish it was a 5 watt range and a something else range, because it just goes off the scale neatly. Right, I've now got to try and get to that one down there. Because I've put this meter in, which stops you getting to this coil easily. We'll now proceed on to L1. Still at 3 watts. And then we'll melt the wax in L2. Don't know what kind of core that is. Let's try. Yes, it is. The yellow one fits. Ah, that brings it up to 3.3. And then we'll well, I can't speak, then melt the wax in L5. And that will bring it beyond 4, so that's great. So that's tuned up. Well, that customer will be pleased about that. I know there isn't a big difference between 2.7 watts and 4 watts in decibels and range, but that will help. It'll give him those extra few hundred yards. So that's done the transmitter. Now we'll do the deviation. Well, the deviation is RV2, and RV2 is the preset down there. So I'll get that oscillator we have out, switch the test set to FM modulation. Now what am I getting? I'm getting 2. Let's just see if we can up that. So it's now 2.5. And I'll just do the whistle test and make sure that's spot on. Wallow. Yep, they're the 2 tests. So we've set the deviation. That was 2. We've brought that up to the 2.5 now, which is going to help with the torque power. Now they've fitted this meter, whoever's turned these into base stations, so we now need to just check that the meter reads something like when I press transmit. It goes far too far across, so we need to adjust that. Now we don't know which. There's 2 presets on the back of this meter. We don't know which is which, and so we're going to find out. It doesn't matter if I upset the other one, because the other one will be a receive. See, if there's 2, I'm bound to guess the wrong one. Okay, the meter now reads 4, and I'm able to write on my notes here that is TX meter, so the one will be RX meter. And that, oh, we need to do frequency, don't we? I was going to say that concludes it, but we just need to do the frequency. There's one crystal because it's the LC7137. Just zoom in on that. So we've got the reference crystal there, which is 10.24, which is on top of the LC7137 IC, and somewhere down there is TC1. Oh, it was in the shadow of a screen plate. I'll just tilt the chassis. Can you now see it reflected? There, that's it. That's TC1. Now it should be 2779125. It's 2779113. So it's dropped slightly, which is exactly what does happen. So just bring that back up. 2779125. That's superb. Right, we'll leave it at that, and the next video will be on the receiver section.